So hello everyone, I hope you all are well and making progress in life. Here is Priyanshu and welcome to the Infinity Mind. So today we'll be solving the problem copy list with random pointers. So we are just given very large problem statement, but if I tell you in short, the problem statement is just saying that we are just given a linked list which has two pointers, next pointer and random pointer. So usually we always deal with a linked list which only have next pointer, but here we have a linked list which have random pointers also. So we can see in this linked list that this consider this node 7, the value 7, and next pointer is pointing to the node 13, the node whose value is 13, and the random pointer is pointing to, we can see, null. All right. Similarly, in the second node, the next pointer is pointing to this node 11, and the random pointer is pointing to the node first, that whose value is 7. All right. And the problem is saying that we just have to copy this list. Means we have to create a deep copy of this linked list. This means we have to create a new linked list, copy of this linked list. All right. New nodes, we have to create whole new linked list with new nodes, and next pointer will be pointing to uh, the corresponding node. We have to create, if I tell you clearly, we will create a node, another node whose value will be 7, and another node whose value will be 13, another whose value will be 11, 10, and then 1, and then whose 7's next pointer will be pointing to 13. Next this next will be pointing to this. Similarly, random pointers we have to keep care that they are pointing to whatever in the original English is there. So we have to create copy. And you must be thinking it's very easy, and yes, it's very, we can say, easy, but uh, we know that if we are given a normal linked list, so what we do, we can just create with, if a normal linked list is given where only next pointers are there, so what we can do, we can just create new linked list, create new node, and put the values and just assign the next pointer of the next node. But here we have to deal with random pointers also. All right. So we cannot say that suppose we created a node 7, and we created a node another 13, and we say that okay, we will point next pointer of 7 to 13, but if we say now go and mark the random pointer, so here the random pointer is pointing to null, okay, we can mark it null, but in this case the random pointer of 13, it's also marking to 7, okay, all right, but here in the third 11, random pointer is pointing to 10. All right, here we can see that 11's next is 10. We will create this, but how can we mark 11's random pointer when the node is not created, because here the random pointer is pointing to 1, and how can we point this to 1 if we haven't created 1 now? So one solution is, what we can do, we can just first of all create all nodes and just uh, sort out the case of next pointers. What we can do, that if I tell you with example, so I have taken this example. So what we can do, we can just go and create the nodes. Suppose I create a node 7 and say that the next will be pointing to new node 13, then its next will be pointing to 11, then its next will be pointing to 10. What I'm doing, it's a strategy that first of all we will keep uh, care of next pointers, so that all the nodes are now created. Now this way my all nodes are created and next pointers are marked. Now we have to just deal with random pointers. So how we can deal with random pointers? So first of all, we are, let's say, here, and I say that what was what was the random pointer pointing, what was the random pointer pointing in the original node. So here, if I am standing here, let's say my new current, let's say this is new current and this is old current. So this was old current, so I should say that this was old current, let's say C, and this is my NC. All right, so here the random pointer is pointing to null, so no problem, we can point to null. But here we as we move forward, so my new current will be here and old current will be here. So here again null pointer will be pointing to null, no problem. Here also pointing to null and here also null. But when we will be here, all right, so we can see that here the random pointer is pointing to 7. So how we know that we are new current here, our new current is here, how we will say that if here the random pointer is pointing to 7, then how we will say that where should our random new currents, here one should be pointing to where, because in the original it is pointing to 7, how we will say that this is pointing to 7, because we don't have track of this 7. All right, and we cannot say just point this to this 7, we cannot say that. We cannot say that just point this to this 7, because we have to create a deep copy and we have to create just another node, and this should be pointing to this 7. All right, so how we can keep track of this? So there is a trick. So there is a trick, that is the first approach. What we can do, we can just use maps. All right, hash maps, unordered map, ordered map. What we can do when we are creating new nodes, so let's say I am at this node, and node's value is 7. So in the map what I can do, so let's say I have this node 7, this is the original one, and I can say that key is the original node and value will be the new node. All right, so I can say that its corresponding value will be the new node, so this will be my new node. All right, so I should say here, this is the, I should say here that key is the original original node. All right, I hope you understood. And value will be the new node, the corresponding new node, the corresponding new node. So if we keep track of this, all right, so we can easily find that if the random pointer is pointing to 7 here, so we can say that here the random pointer will be pointing to map of 7 here. So here map of 7 will be this node, so we can easily point the random pointer. All right, similarly we can just now create a deep copy using hash map, but this will take extra space of big O of n, and the space of creating new nodes, n new nodes are there, so that we have to create. So we can consider that time complexity also. So this will be big O of n time complexity of result, and but extra space complexity of using that hash map, using this unordered map. All right, so there is approach 2 also, where we can solve this question without using this hash map. There is a trick. So what we can do, suppose we are given this example only, and if I try to copy this, if I try to copy this and I paste this here. All right, now we are given this. All right, and So now we are given this, and there is a trick. We can just reduce that hash map time space complexity, sorry, we can reduce that space complexity of reducing hash map. There is a trick. So the trick is, when we create a new node, let's say this was original node, we can, what we can do, we can add, we can add we can add new nodes in between the original nodes. So this will be my original node and this will be my new node. All right, so I'm just, my writing is not good because I'm using mouse. So my circle ones are the new copy nodes, new copy nodes, and my rectangle ones are original nodes, original nodes. All right, so now what I will do, I will just say that my rectangle one, let's say 13 is there, and I will add the copy nodes in between the original nodes. So this will look like this. Now similarly here also, similarly here, next 10 will be here, next 10's copy node will be here. So I'm just shifting this aside. All right, now then this will be pointing to my original node 1, and this will be pointing to my copy node 1. All right, and this will be pointing to null. So I will tell you why I did this, because it's a very trick, it's a, there is a trick. So now this again, this will be this these are my next pointers, and random pointers are already, the random pointers are pointing to to two nodes, uh, as we can see in the original linked list. All right, so here this random pointer of 7 will be pointing to null. I'm just saying that I'm adding new copy nodes in between the original nodes. Now what I can do, in the first step I have just inserted it. In the second step, what I have to do, I will just mark the random pointers. So for suppose my current is here. All right, now I have to mark the random pointers. So my random pointer of this 7 will be what? So here the random pointer of 7 is null. So random pointer of this current is null. So similarly I will say that random pointer of this 7 will also be pointing to null, no problem. So similarly here, no problem, this will be also be null, here also null, here also, here also. But here my random pointer is pointing to 7. So if I have to if my current is here, and I have to say that current is my original node, and current's next will be my copy node. So my current's random pointer will be, was pointing to 7. All right, this random pointer, and now it's my turn to point the copy node's random pointer. So current's random pointer was pointing to this 7 node, and this 1 should be pointing to this copy node of 7. So how I can do this? I can say that current's random, current's current's next pointer, I will say that this copy node's random pointer will be nothing but current's randoms next, current's randoms next. I will just say this. So it's easy for me now to say that my current's next random, current next is my deep copy node. So current's next random will be what? Will be nothing but my current's random's next, because current's random will be my original node and its next will be my copy node. So I can say that current's next random, that is my current's next random, will be pointing to current's random of next. All right, so just this will be my logic. All right, so just this formula I will use, and this way now this new copy node of 1 will be pointing to this new copy node of 7. And now my turn is to now separate them. I can easily separate them. I can use current pointer. I will say current's next pointer will be current's next to next pointer. I will just separate them. It's very easy. So what was the logic? So this approach to logic was just to first was to insert the nodes between the original nodes. Second was to assign the random pointers. All right, and third point was to modify them, to repair them, to just remove the links, to just separate them. I should say separate the new one. This will be now this my 7 next will be 7's next will be not 13, not original 13. My 7's next will be this copy 13, and 13's next will be not copy 13. This will be pointing to 11. This I can do very easily. So these three steps we can do, and we can just say that we are not using any space here. So here extra space complexity we have reduced from using this hash map to big O of 1. But yes, for we are creating new nodes also, so we are using big O of n space for just result, but extra space we are not using any. So if I go and implement this, so if I go and implement this, so I will just use these three steps. I will use just 3 steps here. So my first of all head is given, and I will say that if head is a null pointer, so I can just return null pointer. I don't have to create a copy node. I will just say that return the null pointer. Otherwise, my first step 1 was to insert the copy nodes between original nodes. So how can I do this? I can just stand at the first node. Let's say if I copy this and say that, let's say my current is standing at head, and while my current is alive, I can create a new node, let's say temporary, and this will be my pointing to this. I will create a new node, and whose value will be current's value. All right, current's value or data value, val. All right, now my temporaries next, I will say that my current's next will be pointing to this temporary. All right, but before pointing current next to the temporary, I should have uh, uh, stored this next node. So I will say that next node, let's say current's next node was current's next. All right, now I will mark current's next as temporary. Now my current's next to next will be my current next. All right, Now I will move my current, so current will be next of current. Alright, now my first step is completed. Now I will go to step 2, that is assign random pointers. So how can I do this? Now if I am standing at anywhere, if I am standing at any node, let's say my current is my head only, and I will say while current is alive, if let's say I am standing at any node, here I am standing, alright, my current is here, I have to mark this random node. So I will say my currents next random I have to handle. So this will be what? Currents next random will be nothing but currents random next, as I told you. But suppose currents random comes null pointer, then I will say that my currents next random will be also null pointer. So first I will check that if currents random is existing, then I will say that this will be currents random next, otherwise this will be null pointer. Alright, now after doing this I will keep moving current. So current will be what? Currents next to next. Alright, now my step 2 is also completed. Now what will be my step 3? I will separate new list and original list. So how I can do this? Suppose I am standing at this current node, so let's say my current node is at head now, and so I have to keep track of the new head also. So my current is at head, and I will say my new current will be standing at my new current's head, new list head. So this will be nothing but currents next. Alright, my new current will be standing here, this will be my current, and my new current will be at this node. Alright, and my new head will be what? That I have to return in the answer. I have to return the new head. So my new head will be what? Nothing but new current. Now I have to separate them. So what I will say, that while current is alive, because when current will be null pointer, then my new current will also be null pointer. We can write here also that for safety, that current is alive and new current are also alive, but there is no need, but for safety we can just write it. And now what I have to do, I have to write that currents next will be what? Current next will be what? Currents next to next. Easily, that currents next will be pointing to currents next to next. Currents next will be pointing to currents next to next. Wait, currents next will be pointing to currents next will be pointing to currents next to next. And similarly, new currents next will be pointing to new currents next to next. But yes, if currents next is null pointer, then I will say that currents next is, because see, if here currents next is null pointer, then if it will access the next of the null pointer, then it will give error. So I should say here, if currents, this is a safety check, but we should write this always. So suppose currents next will be what? If it is existing, that then it will check currents next to next. Otherwise, if it's not existing, I will say just assign it null pointer. Similarly, I will write here also that if new currents next is existing, then only I will say that assign it new currents next to next, otherwise null pointer, otherwise it will give error. Now I will move both the pointers. After assigning them, current will be current will come here and new current will come here. So I have to move them one by one. So I will say that current will be next of the current and new current will be new currents next. All right. Now we are ready. We have done all these steps, and at last we have to just return our new head. So if I run this and check if we haven't done any mistake, and there was a mistake in the line 33, that current is assigning to head. It is saying that redefinition of current. Okay, we have already declared current, so we just need to redirect it, not need to declare it. And again in line 40, yes, here also my mistake, I have redeclared current because I have declared once above. Now if I check the sample test cases and memory limit is exceeded, we have done some small mistake anywhere. If head is null pointer, we will return null pointer. In the first step, insert, we have to insert copy nodes. So my starting is at, my current is at head, and while current is alive, I will create a temporary node and I will assign it value of the current, and my currents next will be next of the current for uh, keeping track. So now my currents next will be pointing to temporary. All right, and my currents next to next will be pointing to currents next. All right, and now my currents next will be okay. Now I will move my current. So how will I move my current? If I have assigned a node in between, so I should say my current will be moving to next. Now if I run this and check, yes, we are able to pass the sample test cases. And if I try to submit this, and if I check if we are able to pass all the test cases or not, so yes, we are able to pass all the test cases and we have solved this problem successfully now. And if I tell you this time and space complexity, so we can say that here we are traveling, while inserting we are traveling the nodes once. Here also we assigning random pointers, we are traveling the nodes once, and here also while separating we are traveling the all the nodes once. So I can say that time complexity is big O of n, where n is the size of the linked list, and space complexity, I would say that for storing the nodes, for that the question is asking we have to create n new nodes. So for that I am saying that big O of n for new nodes as a result, but I will say that big O of 1, I should say, but no extra space, I am taking. So no extra space I am taking, so that's why for this is big O of 1, because no extra spaces I have taken. This is just resultant. This big O of n space is for new nodes as a result. So yes, for according to the rules, according to the code, time and space complexity is big O of n, but we are not using any extra space. All right, so this was all about this problem. I hope you understood. Thanks for watching. Till then, keep learning and keep upgrading yourself. See you in the next video.